See, ma'am. So fluid flow. Now we are studying about, we are considering which kind of fluids, ideal fluids. Ideal fluids means what? Already we discussed, no, but they cannot be compressed. We cannot compress them. Their volume cannot be changed. And also, we are considering that there are no viscous forces existing between them from here onwards. Viscosity we have studied. But from here onwards, we are considering viscous forces to be 0. Okay? And the methods in which a liquid can flow is two types. Liquid can flow as a steady flow, which you can call it as a laminar flow. And liquid can flow like a turbulent flow also, unsteady flow, irregular flow. Okay? So what is the difference between a steady flow and non-steady flow or turbulent flow? Let us say, see, ma'am. So all the molecules, consider they are moving like this. Water molecules or any fluid molecules or liquid molecules, they are moving like this. Okay, ma'am? So this is particle number 1, this is particle number 2, this is 3, this is 4, and this is 5. All of them, they are moving in this direction. So after some time, after a time of t, okay, ma'am? After a time of t also, the arrangement of these molecules will never change. Okay, ma'am? So 1, 2, 3, 4, 5, they are moving in the same fashion. Then this type of flow, I can call it as a steady flow. Okay, ma'am? It means the arrangement of the molecules is not changing. They are moving in the same fashion. Okay? Goods bandilaga veltu unte steady flow. Okay? Similarly, for example, this is 1, 2, 3, 4, 5 molecules. Okay? And after some time, okay, molecules are present like this. So this is 2, this is 1, this is 4, this is 3, and this is the 5th molecule. So now what is happening to their arrangement? Arrangement is not same. It means one molecule is jumping over other molecule. And after some time again the arrangement doesn't remain same. Then this type of flow I can call it as turbulent flow. Turbulent flow, or you can call it as a unsteady flow. This is laminar flow, this is turbulent flow. Okay? So these are the types of flows which you should remember. Okay? And here, to identify which one is steady and which one is turbulent, we have a number which is called as Reynolds number. By using that number, we can identify whether a flow is a steady flow or whether it is a turbulent flow. Okay? So therefore, write down. Okay? Type of flow can be identified by Reynolds number. Okay? And what is this Reynolds number, ma? So Reynolds number n is equals to rho v d divided by eta. Okay, ma? Rho v d divided by eta. This is called as Reynolds number. Okay? So what is meant by rho? Rho is called density of liquid. Okay, ma? V is called velocity of liquid. D is called, capital D is called diameter of pipe. Okay, ma? Eta is called as coefficient of viscosity. Okay? So, clear, ma? So this Reynolds number, if it is less than 2000, ma, then it is called laminar flow. Okay? If I do this total calculation, density of liquid, velocity of liquid, diameter of pipe divided by eta value. If I do this total calculation, if I get NR value is less than 2000, then such type of flow I can call it as a laminar flow. Okay, ma? And if NR value is between 2000 and 3000, then you can call it as a turbulent flow. Okay, ma? So not a very important concept, but you should remember this one. Understood, no, ma? So just by looking at the value of NR, we can identify whether flow is a steady flow or unsteady flow. Okay? You should have seen in pipes now, if water is flowing very smoothly, you can call it as a steady flow. If water is continuously mixing with each other, then it is called as turbulent flow. That's it. Okay. So keep the next concept, rate of flow. Rate of flow. Okay, ma? So volume of liquid or fluid also you can call now. Volume of liquid flowing through a cross section. Through a cross section in unit time is called rate of flow. Okay, ma? So it means that how much liquid, how much quantity of liquid is flowing through a pipe in 1 second. That is called as rate of flow. You can represent this 1 by Q. Q is equals to V by T, ma. Okay? V means what? Volume of liquid. How much volume of liquid is flowing in a time of 1 second. That is called as rate of flow. Volume can be written as mass by density, no ma? Density is equals to mass by volume. So volume can be written as mass by density multiplied by T. Okay? Mass by density divided by T I can write. So Q is equals to mass, or I can do one thing, ma. Instead of using mass by density, let us do one thing. Q is equals to, see ma, for example, if you take a pipe, okay? So this much of liquid is flowing in a pipe in 1 second. This much volume of liquid is crossing this cross section in 1 second. It means this total water will leave this pipe in 1 second. Okay. Then this is called volume of the pipe only, no? Then volume, how can I calculate? I can calculate by using area of cross section multiplied by length. This method also I can follow, no? Area of cross section of the pipe multiplied by length of water column, which will leave that cross section in 1 second. That is called as total volume of water. Okay. So volume, I can write area of cross section into length divided by time. Length means what? Length of water which crosses this cross section in 1 second. Okay. So length by time is also called as velocity, no? Velocity of water. So therefore Q can be written as area of cross section multiplied by velocity. So this is one more formula to calculate rate of flow. Are you able to understand? So area of cross section of the pipe multiplied by velocity of the liquid. That is called as rate of flow. Are you able to understand how we have derived, ma? Volume of liquid crossing a cross section in unit time. So how much volume of liquid is crossing a cross section? Length L of the liquid is crossing an area of cross section of A. So this much liquid will go, no? So velocity, how can I calculate? Length by time is nothing but velocity. Okay. So therefore A is called what? A is called area of cross section of pipe. Area of cross section of pipe. Okay, ma? And V is called as velocity of liquid. Velocity of liquid. So therefore these are the two formulae to calculate rate of flow. One is velocity by time, another one is area of cross section multiplied by velocity. Okay. Now keep the next side heading, very, very important concept, equation of continuity. Equation of continuity. Okay, ma? So equation of continuity. What is the meaning of this one? Let us see. See, ma. So consider this is a pipe. Okay, my pipe is like this. So here it is having an area of cross section A1, and here it is having an area of cross section A2. One thing which I can understand is definitely A1 is greater than A2, no? Here pipe is having bigger cross section, here pipe is having a smaller cross section, and this is the liquid which is flowing out of the pipe. Okay. So one thing which I can say is that, see ma, from here, if 1 liter water enters per 1 second, then from here also 1 liter of water should go out in 1 second. This is understandable, no? what is the volume of liquid entering the pipe, same volume of water should come out also. Because inside the pipe there is no storage. Storage is not there, no? ఎంత వాటర్ ఈ వైపు ఎంటర్ అవుతుందో అంతే వాటర్ ఆ వైపు నుంచి బయటికి కూడా రావాలి. ఓకే, సో వాల్యూమ్ ఆఫ్ వాటర్ పర్ సెకండ్ ఈజ్ నథింగ్ బట్ రేట్ ఆఫ్ ఫ్లో నమ్మా. సో దేర్ ఫర్ హియర్ రేట్ ఆఫ్ flow if it is Q1, here the rate of discharge if it is Q2, definitely I can say Q1 and Q2 they should be equal. Understood, no? Why they are equal? Because inside the pipe there is no storage. Storage is not there. If 1 liter is entering in 1 second, same 1 liter should come outside also. And what is Q value? A1 V1 is equals to A2 V2. This equation is nothing but the equation of continuity. Are you able to understand? So when you look at this equation, what do you understand? A equation చూస్తే మీకేం అర్థమైంది? Anything which you understand? Oh, still? What we understand is, Sima, area of cross section is very large on one side, no? So therefore velocity of the water will be very less. Clear, no? And here area of cross section is very small, no? So liquid will be coming out of this pipe with a huge velocity. This is what we have to understand. Because A1 V1 should be equal to A2 V2, nama. If one value is very large, other value should be very small. Okay? So therefore what we write, therefore, if area of cross section, is very small, okay ma, then liquid should come out with a very high velocity. Liquid should come out, okay ma, with high velocity. So this is the point which we should understand. Clear, no? So here water is entering very slowly, but same 1 liter of water in 1 second. But here water is coming with very high speed. Why? Because area of cross section is very small. Are you able to understand? So this is an important concept. Okay, ma? See, even while you are gardening water, okay ma, then pipe ki meer atla finger addam pedtaru gurtunda. Okay ma, to the pipe you keep your finger. What is the reason? So that water travels with a greater velocity and it falls to the plants which are very far away. What is the technique you are using? Same one. So if area of cross section becomes very small, by closing your thumb, velocity of water increases. If velocity of water increases, water can travel a greater distance. That is called as equation of continuity. Are you able to understand, ma? Similarly, for example, if I give you one case, Sima. So consider this is a rainy season, okay ma, and a bridge is broken down and you want to cross over that bridge. Okay, so you have two options. Either you can move your car from here, or either you can move your car from here. If you move the car from here, you can pass on very easily, but here depth of water is very large, no ma? So how can you identify? This one you are not able to see. Water flow is above the bridge, no? This you are not able to see. So how can you identify from where you have to pass your car? If you pass your car from here, you can safely pass. ఇక్కడ నుంచి కారు పోనిచ్చినారు అనుకోండి, పోతుంది కారు, వాటర్ లోపల ఉంటుంది అనమాట. This is the bridge. You have to pass like this. Or consider this is some river bed, ma. Some river bed. Are you able to understand? From where it is safe to pass your car? From this position or this position? Position number 1, position number. Definitely you will prefer this position, no? If you pass your car from here, very easily you can go to the other side. But how can you identify whether you have to pass from here or you have to pass from? Water? Velocity. So by where can you say velocity is more, where velocity is lesser? See ma, here the area of cross section is very large, no? Okay ma? The water is moving in a very huge area of cross section. So here, if area of cross section is very large, automatically liquid will be flowing very slowly. Okay, ma? And this total water should pass through this small area of cross section, no, ma? Here area of cross section is this much. Here area of cross section is very small. Clear, no? So when same water passes from here, then liquid will be flowing very fast. So you have to select that spot where liquid is flowing very, very, very fastly. It means the depth is very small there. Are you able to understand, ma? Sloga veltundi kada ani cheppi ikkada nunchi car pass chesinaru anukondi ante inga meeru. Is it clear what is happening? This is called as area of cross section. Here also there is no storage, no, ma? Whatever water is entering, same amount of water should leave also. Okay? So here area of cross section is very small, here velocity will be very large. So you have to pass your car from that place where velocity of the water is very high. Then you can pass on very easily. Is it clear? That's idi oka application. Okay, ma. See, ma. So next we are studying about energy possessed by the liquid, ma. Okay, flowing liquid has 3 energies. What are the 3 energies possessed by liquid? Liquid has pressure, no, ma? Liquid has pressure, no? No? So pressure energy per unit volume we have to take. And pressure energy per unit volume is equivalent to pressure itself. And that calculation is there, we need not remember, just remember that point. Clear, no, ma? Pressure energy per unit volume is nothing but pressure itself. Okay? Then liquid is flowing, no? Because liquid is flowing, it has kinetic energy. So kinetic energy per unit volume. So half mv square by volume, mass by volume is density, no? Half rho v square. Similarly, when compared to this liquid is at a greater height, no, ma? So therefore potential energy also is there. So therefore third energy is potential energy per unit volume. So potential energy mgh by v, again mass by volume is called density, rho gh. So liquid has 3 types of energies. Pressure energy per unit volume, nothing but pressure. Kinetic energy per unit volume, half rho v square. Potential energy per unit volume, rho gh. Okay. So then we study a theorem which is called as Bernoulli's theorem. Okay, ma? Bernoulli's theorem. So Bernoulli's theorem says that total energy of any fluid, okay, ma, is always constant. This is called as Bernoulli's theorem, which is according to law of conservation of energy itself. Okay, Bernoulli's theorem is not a new theorem. It is based on law of conservation of energy. Total energy always remains constant, same concept. But the point is that this theorem was identified before identifying law of conservation of energy. So that is why it was given a separate name called Bernoulli's theorem. Are you able to understand, ma? Ikkada kuda law of conservation of energy ne vaadtam manam. Kaakapote idi law of conservation of energy ni identify cheyaka munde idi identify chesinadu Bernoulli ane scientist. So that's why it is given as the name of Bernoulli theorem. Okay. So therefore I say total energy of a fluid is always a constant. So how many energies a fluid has? 3 energies. So sum of all these 3 energies, pressure plus half rho v square plus rho gh should be constant. Okay. This is called as Bernoulli's theorem. Very simple. Sum of all the 3 energies always remains constant. It means if you calculate energy here and if you calculate energy here, if you compare both of them, they will be equal. Okay. Or I can do one thing. Here pressure energy is P1. Here velocity of the liquid is half rho V1 square. Okay, ma? And here height is, here there is no height, no? If I take this reference to be 0 reference, then height is 0. Clear, no, ma? Or you can do one thing, let us take this height also to be height h1, ma? h1 height, let us take this height is h2 height. Therefore, how I can write rho g h1. Okay, ma? So this is the total energy possessed on one side of the tube. And if you take the total energy on the other side, how I can write pressure energy is P2, kinetic energy per unit volume is half rho V2 square, and pressure energy per unit volume is half rho G H2. Then I see that both of them, they must be equal. This is called as Bernoulli's theorem. Okay, ma? So, okay. So see this question on Bernoulli's theorem. So a pipe is running full of water. At a certain point, it tapers from 60 centimeter diameter to 20 centimeter diameter at B. It means this is a horizontal pipe. How can we say it is a horizontal pipe? Because he did not give about any inclination of the pipe, no? So we consider the pipe to be horizontal. Clear? And what is the shape of this pipe? It is tapering from 60 centimeter diameter to 20 centimeter diameter. It means I can say that, let us consider shape of the pipe, let it be like this, for example. Clear? So here what is the diameter? Diameter is 60 centimeter and here diameter of the pipe is 20 centimeter. Clear number? So this is the first information which he gave. And the pressure difference between A and B is 100 centimeters of water column. Okay, ma? So here, if pressure is PA and at this point pressure is PB, then pressure difference is how much? PA minus PB is 100 centimeters of water column. Okay. Now can you say what is meant by 100 centimeters of water column? 100 centimeters of water column means how can I calculate pressure? Already we said no, pressure can be measured in terms of height of the liquid column also. Last chapter lo pressure can be measured in terms of height of the liquid column also. So what is the formula to calculate pressure due to height of a liquid column? Rho Hg, then apply that. Rho Hg. That's all, no? So density of water. Water column only we have to take density of water itself. Density of water 1000 and height of water 100 centimeter. 100 centimeters means 1 meter, no? Clear, no? And G value is 10. So how much? 10 power 4 Pascal or Newton per meter square. Clear, no? So this is the pressure difference between point A and point B. So it may be pressure at point A is at a higher pressure and B is at a lower pressure. So water always flows in which direction? Water always flows from higher pressure region to lower pressure region. So this point is at a higher pressure region, this point is at a lower pressure region. So pressure difference is 10 power 4 Pascal. One point we got clarity, no? Then find the rate of flow through the pipe. So rate of flow means what? Total volume of liquid flowing per second, or I can call it as area of cross section into velocity. I can calculate like this also, no? So this value we are supposed to calculate. Are you able to understand, ma? So area of cross section on one side I can calculate by using pi r square, because diameter is given, no? If diameter is given, radius is half of it. Clear, no? Then area of cross section of the pipe is pi r square. Pipe will be in the form of circle only, no? Pi r square. But area, what is the velocity of water? That I don't know. That how can I calculate? Can you say? Velocity of water. How can you use kinematics here? No. Anybody? This is only pressure difference only. Pressure difference measured in terms of height of the liquid column. Now I want velocity. What is the speed of water at any cross section that I want to calculate? Bernoulli's equation we have to apply. Are you able to understand? What is Bernoulli's equation? So pressure energy per unit volume, kinetic energy per unit volume, potential energy per unit volume should be a constant. This is Bernoulli's theorem. Now I will apply Bernoulli's theorem at two different points. So if I compare energy at point A and energy at point B, both energies should be equal. So therefore I will say that pressure at point A plus half rho, velocity at point A plus rho Hg. Sigma. Okay, I will write rho Hg. So this is equals to pressure at point B plus half rho velocity at point B square plus rho Hg. Okay. Now what is meant by rho Hg? Rho Hg means potential energy per unit volume, no? Sima, yesterday we have derived potential energy per unit volume. What is the formula of potential energy? mgh. mgh per unit volume. So mass by volume is nothing but density. Clear? Now what kind of pipe you are taking? Horizontal pipe. Horizontal pipe means point A and point B, both of them they are at the same height, no? A and B they are at the same height. If height is same, potential energy remains same. Are you able to understand? So therefore I will write points A and B are at same height. Okay? So they are at same height, therefore potential energy at point A must be equal to potential energy at point B. So therefore what I can do, I can cancel the potential energy per unit volume because they are equal. Are you able to understand? Now what is the equation I am left with? PA plus half rho VA square, clear no? So this is equals to PB plus half rho VB square. I am left with this one. Okay. Now what is PA and what is PB? Pressure energy per unit volume at point A. PB is pressure energy per unit volume at point B. And pressure energy per unit volume is nothing but pressure. Already I said you yesterday, no? Pressure energy per unit volume is nothing but pressure itself. So therefore I can write PA minus PB. This is equals to half rho. If I take common, then it can be written as VB square minus VA square. So I got equation up to here. Okay. Now what is PA minus PB? Pressure difference only, no? PA is pressure at point B, point A, PB is pressure at point B. So that pressure difference already we have calculated, no? 10 power 4. So substitute here. Okay. First make a note up to here. Now see. So therefore, so pressure difference is how much? Pressure difference is 10 power 4 Pascal. So half density of water is how much? 1000 multiplied by, I am left with VB square minus VA square. Okay, ma? So what is VB square and what is VA square, ma? They are nothing but velocities at point A and point B. So velocities, are they given? They are not given, no? So how can I calculate? So I will use one thing. I will use equation of continuity. Okay, ma? Equation of continuity. What is equation of continuity? It is nothing but A1 V1 is equals to A2 V2. This is equation of continuity, no? Clear, no? So the rate of flow of liquid at one cross section is equals to rate of flow of liquid at second cross section. Already we discussed yesterday, no? So what is the formula of area? Pi d1 by 2 whole square multiplied by V1 is equals to pi d2 by 2 whole square multiplied by V2. Okay, ma? So pi 2 and 2 get cancelled. What is the diameter at one end, ma? 60, no? So 60 square. No need of converting into meters, ma? So another side 20, no? So 20 square multiplied by V2. Okay. So therefore V2 means this is VA and this one is VB. Clear? So either I can calculate VA or I can calculate VB. Anything I can calculate. Which one shall we calculate? Anyone we will calculate, ma? So 60 into 60 multiplied by VA is equals to 20 into 20 multiplied by VB. So 0, 0, 0, 0 get cancelled. So 2 1s are 2 3s are 2 1s are 2 3s are. So therefore 9 VA is equals to VB. That's all. 9 VA is equals to VB. So take this value and substitute in this equation. Then either you will get VA or you will get VB. So which one shall we calculate? Instead of 9 VA, I can substitute VB number. That is better. So 10 power 4 is equals to half into 1000 into. So I will write VB to be VB only. And instead of VB, I can write 9 VA whole square minus VA square. I can write like this. Okay, ma? So therefore 1000 and 3 get cancelled. So 10 is equals to 1 by 2 into 81 VA square minus VA square. Okay. So therefore 10 is equals to 1 by 2 into 80 VA square. Okay, ma? So 2 1s are 2 40s are. So therefore VA square is how much? VA square is equals to 10 by 40. So therefore it is 1 by 4. So therefore VA is equals to 1 by 2 meters per second. So I got velocity at point A, no? Are you able to understand, ma? What is meant by VA? Velocity of the liquid at point A. Okay. So therefore how can I calculate rate of flow? Rate of flow. Rate of flow Q is equals to A into V number V into A. So A1 V1. What is the area of cross section at the point A? So it is pi dA by 2 whole square multiplied by velocity at point A is 1 by 2. That's all, Amma. So therefore, if you do this calculation, I will do here. Okay. So therefore, Q is equals to pi. So 60 centimeters, Amma. Now you need to convert that one into meters. Okay. So 0.6 meters divided by 2 whole square multiplied by 1 by 2. So Q is equals to pi into 0.3 whole square multiplied by 1 by 2. So just do this calculation. That is the rate of flow at point A. That's it. Clear, Nama? So have you understood how we have calculated? So it is approximately 0.14. 0.14 area of cross section into meter square per second. Okay, that is how we do the calculation. Have you understood, ma? So what are the two equations we have used here? One is Bernoulli's theorem, another one is equation of continuity. Those two equations we have used. Okay, right on. Okay, ma? See, ma. So the reading of a pressure meter attached to a closed pipe is this much, my initial reading. Then what we are doing, we are opening this valve of a pipe. Okay. Then what happens? Immediately water starts flowing, no, ma? If water starts flowing, then pressure has reduced to 2 into 10 power 5, but pressure is increasing here. 1 minute more, let us see the data. 2.5 into 10 power 5. This is 10 power 5, ma. 10 power 5. So the reading of pressure meter reduces to 2 into 10 power 5 Newton per meter square. Then calculate the speed of water after opening. That is the question. So let us try to understand first of all what is happening here, Masima. So consider this is a pipe. Okay. So previously it was closed. It was a closed pipe. Okay. So here some tank. So consider some tank. Something is present here. Okay. So water is present in this one. And this side, it is closed initially, and here there is a pressure meter which measures the pressure of this water. Okay. So before opening, what was the pressure, ma? Before opening this pipe, initial pressure was how much? It was 2.5 into 10 power 5 Newton per meter square. Okay. So after we open this pipe, open means we open this opening and water starts flowing. Okay, ma? So after opening, final pressure is how much? It is 2 into 10 power 5 Newton per meter square. Clear, no? So pressure reduced, no, ma? Initial pressure was 2.5, but final pressure is only 2. Can you say why pressure has reduced? Why pressure has reduced, ma? Water is flowing. If water flows, why pressure should reduce? If water starts flowing, why pressure should reduce? That's the Bernoulli theorem which we have studied, no? Total energy of liquid should be what? It should be constant. This is what we have written, no? Clear, no? What are the different kinds of energy? Pressure energy, kinetic energy plus unit volume, potential energy per unit volume, they should be constant. Clear, no? This is the equation. So total energy is remaining constant means that if one energy increases, other energy decreases. That is the meaning of this one, no? So liquid has three types of energy, no? Pressure energy is there, kinetic energy is there, potential energy is also there. So if one energy increases, what should happen to another energy? It should reduce, no? So when you open this pipe, which energy is increasing? When you open the pipe, which energy is increasing, no? When you open, liquid starts flowing, no? Liquid starts flowing means which energy? Kinetic energy is increasing. Clear, no? When you open the pipe, liquid starts flowing, no? Immediately which energy increases? Kinetic energy increases. So if one energy increases, another energy should decrease, no? What is the another energy which can decrease? Potential energy cannot decrease because pipe is present at the same level, no? Height of the pipe is not changing. So therefore, if velocity of liquid increases, the kinetic energy of liquid increases. And if kinetic energy increases, clear, no? Pressure energy should decrease. That is the reason. Okay, so therefore what you write here, as kinetic energy of liquid is increasing or is increased, okay ma, pressure energy per unit volume should decrease. Okay ma? Why? Because total energy is always a constant, no? If one energy increases, another energy decreases. Okay. So therefore, I can use Bernoulli's theorem, no? What is Bernoulli's theorem? This is the Bernoulli's theorem. Okay. So P1 plus half rho V1 square plus rho GH is equals to P2 plus half rho V2 square plus rho GH. Both of them, they should be equal. Clear? So this is the energy before opening and this is the energy after opening. Total energy should be constant. Is it clear? Pipe height of the pipe is remaining same number, so this energy gets cancelled. Which energy? Potential energy. Potential energy per unit volume is same, no? So before opening and after opening same energy, so therefore I will cancel it. Okay. So what was the initial pressure? Initial pressure was 2.5 into 10 power 5. Okay, ma? Plus half rho V1 square. And what was initial velocity, ma? Before opening, what was the velocity of liquid? 0. Clear, no? So instead of V1 square, what I can write? 0 square. Clear, no? So this is equals to final pressure. After opening, what is the pressure? 2 into 10 power 5 plus half rho V2 square. Okay, ma? So here what is the only unknown quantity we have? V2. Density of water already we know, no? Density of water is how much? 1000. So calculate V2 from this one. That is my required answer. Is it clear, ma? So if you do the calculation, the answer which you should get is 10 meters per second. Okay, ma? 10 meters per second. So that is the velocity of the liquid. Amma? This. I pen the exam. Understood, no? Right.